Previously, we talked about frequency, which determines the pitch of the sound you're hearing. The other important part of measuring a sound is its amplitude. In technical terms, amplitude is a level of change in the oscillation of atmospheric pressure caused by sound waves. In simpler terms, amplitude refers to the loudness of the sound. The higher the amplitude, the more powerful it is, so the more air it's pushing around and the louder it sounds. Quieter sounds are not as powerful, so they push less air around. So together, frequency and amplitude give you the pitch and loudness of a sound wave. In Audition, you'll probably spend most of your time working here with the waveform editor. We have an entire chapter coming up in which I'll go into detail, but basically, the waveform editor displays your audio file as a waveform, where time is measured on the horizontal axis and amplitude is measured on the vertical axis. The height of the peaks you see here tell you how loud the sound is at any given time. Amplitude is measured in decibels or dB, and you can see the scale here over here on the right. If I use my mouse, I can actually scroll in to see more increments. But basically, no sound is represented by this negative infinite symbol. And that's represented by the horizontal line that runs through the waveform editor. Any deviations from this center line, whether it's the peaks above or below the line, represents sound. So throughout this course, when I'm referring to a sound's amplitude, you'll know that I'm speaking about its loudness or volume. Now, this has been a very brief discussion of frequency and amplitude. If you'd like a much more in-depth explanation, I highly suggest you check out the course called Foundations of Audio, EQ, and Filters by Brian Lee White, which you'll find on the lynda.com online training library. You'll find an early chapter in that course called Understanding Frequency and Amplitude, which will increase your understanding of these two important concepts.